School wasn't even 2 hours late this morning. Why wouldn't we have practice?
Who do you wrestle at practice?
Logan Bach.
Brianna Gook?
Yeah, he's alright.
Our stuff kicks his ass.
His cross.
All right, take out your Chapter 7 notes, please,
God.
and find Section
Geez, I
7.2.
don't even know if I got these damn things anymore.
Dang things, watching language.
I got my old one.
New Year, same seagull.
New Year, no language.
My book's still on the desk. No, Ryder.
No. I don't understand why swear words are still swear words.
Should be able
Why
to
can't they
serve
just
whatever.
be a normal word?
It's just an interjection.
I mean, I could say frick, and I'm using it the same way I'd use. I just don't understand.
Oh, I'm gonna have a heart attack.
Yeah, me too. Gotta go to practice after school.
I gotta go to work.
Rather
I hate
than
car
go-
results. Rambo.
That's so
John, you better come to school.
Alright.
Yeah, it's gonna be a struggle.
Why, you don't want to say popcorn?
This?
I am gonna stop in there after school.
You better. I'll be there.
Okay, this is going to be a short lesson today. Today we're just going to look at atomic mass and chemical formulas. And I think this might be the toughest part of today's lecture, looking at atomic mass. So remember, atomic mass is the pink number on the periodic table, and you'll notice that they are decimals or whole numbers. Does anyone remember how to find the atomic mass? This is like way back in chapter. You add what to what?
The molar mass? Am I on something?
Not really.
No.
How do you
okay.
find like the atomic? Okay, what's the
Yeah.
atomic number?
The black.
The black number. That's the number of protons.
Add that with the red number.
No.
This way. So that's the black number, but the red number. How do we find the red number?
Well, you subtract. and then
Right.
Yeah.
So you add your protons and your neutrons. Now, carbon has three forms. You can have carbon 12, carbon 13, and carbon 14. The only reason why I'm using my pen is I'm actually recording this lecture for Tate. So how many protons are in carbon 12? Protons. Protons.
Is it this thing, baby?
Carbon 12.
Yep.
6.
6. How many protons are in carbon 13?
7. Oh, wait.
Protons.
6.
6.
6.
Okay, but then the number of neutrons change,
Yeah,
right?
7 and 8.
So if I were to find the mass number of these, I mean, these are the mass numbers. Notice that they're nice round numbers without any decimals. So today we're going to look at how did we get these pink numbers? You know, why is it 0.9 or 0.8? Where did these decimals come from? So the molar mass on the periodic table are close to whole numbers, but not exactly. And the reason for that is they take into account all of the known isotopes in the universe, and they figure out the average number from the amount of all those known isotopes. So the average atomic mass is a weighted average of the masses of all the naturally occurring isotopes of that element. To figure out the average atomic mass, you need two things. The mass of the isotope you're looking at and what percent it occurs in the universe. And you'll just multiply those two and then add everything up at the end. So here's an example. The mass of copper-63 atom is 62.94 AMUs, and that of copper-65 is 64.93. Using the data, find the average atomic mass of copper. So here they give me copper-63 and copper-65, and they give me a percentage of what it occurs in. So all I'm going to do is take the mass of copper-63, take it times 69.17. I'll just do this for you.
Do we have to write that chart down, or just start?
Nope.
You're not even going to really want to
Wait, so you go
Looks at it.
62.94 times 69.17.
Yeah, I took 63 times that.
Yeah.
Okay. Now remember, this is a percent, so I had to put it into decimal form. Just gotta move the decimal place over 2. If I take 65 times 0.3083, I get 20.0395. And then all I'm going to do is add them up. And I get 63.6. And if I look on my periodic table, it's 63.54. So it's pretty close. I'm only off by a 10th. I wouldn't mark you wrong. Looking for ballpark numbers here.
So 63 base. Rounded 1 decimal.
Okay, here's another example. Chlorine exists as Cl35, so I'm just going to write that underneath, which has a mass of 34.969. So I'm just going to write that. And it makes up 75.8% of chlorine atoms. So what's that in decimal form?
8.758.
You're so smart.
Then they give me chlorine 37. Says the rest is naturally occurring chlorine, 37 with a mass of 36.996. What's the weighted average atomic mass? And they don't give me the percent. How can I figure out the rest of the percent?
Oh, just divide the percent by the top number. Figure out.
Well, the other one exists as 75.8%, so how can I figure out the other half?
A little more. Just figure in like 76.3 or 4.
You just subtract.
You just subtract it from 1 or 100. Thank you.
Oh, is that
Because remember,
right?
percents equal 100 or 1.
Well, yeah, but
I was
how
just
come that one's 75% and that one's only going to be 25.2?
because that's
Or
just the way it is in the
24.2.
universe. I
Just
don't
the
know.
way she goes.
Well, it's not really the way of the road.
Okay, so if I
because
take 1 minus
it can't be the way of the
0.758.
road.
0.242.
Thank you. So then that number goes here. Cool. So now I'm just going to take my calculator and multiply these two numbers and then add them both up at the end. So 0.758 times 34.6. So I for the top I got 26.5 roughly, and for the bottom 8.95.
Would there be a label on there?
It's going to be AMUs. I don't think I labeled my last one.
I don't think so.
So if I add these two up, I get 35.45 AMUs. And if I look at the periodic table, look, it's 35.45. We did it right. Yay.
So couldn't you just look at that right away?
You have to show your work.
Haha.
So why is
So you just look to check your answer.
Right. At the end. You just can't
Wait,
read
where'd
these.
you look?
the pink number?
On
number
chlorine?
Yeah, it tells you the answer. That's on my case.
Oh, so I have a what's like the chlorine dash 35? What's the 35 mean?
That's isotope 35, and this is isotope 37.
So what's
So
that
it's
mean?
like carbon 12, carbon 13, carbon 14.
So what's that mean? Like it's
There's
Like
more
there's
than
like-
one form. So they both have 17 protons, but their number of neutrons are different.
oh.
So this one has 2 more neutrons.
So why is
than
it
that one.
such a difference if there's only 2 more neutrons?
Such a difference as
Well, like at the end.
26.5, and then it's 8.95.
oh, because
Yeah.
this only occurs 24% of the population.
Oh,
Versus
because
75.
only 20. Okay.
And then another thing you can look at when you look at the average atomic mass it's 35.45. So when you look at the two isotopes, you can say there's definitely more chlorine 35 than 37. If this number was closer to 37, then this would have a higher percent versus that. Okay, this one's about uranium. U234 makes up 0.00500% of uranium atoms and has a mass of 234.041. So I'm going to write down the mass. And I'm going to take the mass times the percent in a decimal form. So this is percent. That means I have to move it out even more.
So it's like 0.00050.
But how can you move that over?
Because it's a percent.
So
This is not decimal.
automatically.
Yep, move it over to U235
No.
has a mass of 235.044 AMUs. The percent is 0.720. Oh, that's a percent. So.
So 0.0072.
Mm-hmm.
Sucks.
Yeah, Davey, whatever.
And there's a third isotope.
238U.
238U, yes. And the mass is 238.051 AMU times the percent.
0.99275.
Oops.
Who's buying? I'll buy it.
Okay, so you're just going to take 234.041 times 0.00005.
So is that a 9275?
0.99275, yes.
Yeah,
Can we put it in coolers?
I get 0.011. Then for the second one, 235.044 times 0.0072.
Maybe a little bit bigger.
Not much. 1.69.
Actually, it's pretty big compared to those.
38.051 times 0.99275.
This one's gonna be huge. Yeah.
That's tiny.
So now I'm going to add up all three of these.
So about 240 or 237, 238, 239, something like that. Let's see. 238. No, 239, right? Oh.
What was that cookie?
I shouldn't have done that.
238.0.
What?
What kind of noise you making over there?
So you're gonna set my fish off.
What did you get?
238.021.
Is that what anyone else got?
I did not do it, but I was figuring in 239.
Here, I'll add her up.
I got a whole
What'd
extra
you
one
get?
in there.
So I just did this all by hand.
Because that's going to be 238 point. 238 point, like,
It should be
Uh,
021,
point
shouldn't it?
02.
238.031.
Okay, that's what I got.
031?
That's what I got.
And then
Oh,
it's
yeah.
AMU.
Forgot to add
Good thing I brought my big hand.
Okay, and if we look at the periodic table, the pink number, 238.0. It's pretty
Couldn't
good.
get rid of a 30.
No, you just leave it like that because then I know you actually did it.
Yeah.
You just didn't look at the periodic table.
Okay, so that's average atomic mass. Now the second thing I want to teach you is chemical formulas. So you guys know that chemical formulas tell you what is in the chemical, but it also tells you how many atoms you have of each. So KBr, how many potassiums do I have?
1.
and Br is 1, so it's a 1-to-1 ratio. So formulas do give ratios even of a polyatomic ion. So I have KNO3. NO3 is the polyatomic ion. It's still a 1-to-1, but how many potassiums do I have?
1.
How many nitrogens?
One.
How many oxygens? 3, okay? So just know that the subscripts actually do mean something. So we can use formulas to calculate molar masses, and this is actually really, really simple. So
Even easier than the last.
way easier. So here I have zinc chloride. The first step, write down zinc, okay? And you have how many zincs?
1.
1. And if I look at the molar mass of zinc, it's 65.37. And then chlorine, how many chlorines do I have?
2.
2. And the molar mass of chlorine is
35.
35.45. So then all I do is just multiply across and then I'll add them up.
70.9. No, 70.9. Then you gotta add those two.
Mm-hmm.
You don't have to,
99.82.
Dave,
Dave.
70 plus 65.
Oh shoot, I had wrote down.
Jesus.
God. I thought the bottom one was
Try
only
like
one correct
one-
times or by 2.
136.
140, somewhere around there.
27. But
Alright, try this again.
Vinny, I put down.
Yeah. 99.
The unit for this, I should say, is actually grams per mole, because it's molar mass. So it's mass with moles. So if you had zinc chloride and you wanted to measure out 1 mole of zinc chloride, you would have to measure out 136.27 grams to get your mole.
NH
Dave, nobody ever said you
equals
stupid.
4
Okay,
times.
this
I
one.
ain't stupid.
What is NH?
So I have
He's a genius.
He's a math prodigy.
This is science, so that's why I messed up.
Yeah, just think if we were doing math, Dave.
It would have been right first time.
Yeah,
First
because
time. Fisher would have laughed.
Fisher would have told you to get out of his goddamn class.
okay, NH42SO4. So break it down. We have nitrogen.
1.
How many nitrogens do we have?
1. 4. Sounds simple. Oh, 2. Oh,
She
yeah.
got a mic.
I think so.
What's the molar mass of nitrogen?
14.01.
Then we have hydrogen. How
So
many
is that
hydrogens?
6 or 8?
Nope, 8. Multiply.
Hydrogen is going to be 4.
So 2 times 4 is 8.
Yeah.
Molar mass of hydrogen?
1.01.
Hydrogen is 8? Okay.
That's
2
what
times
they
4.
claim, because, you gotta boil it out,
Yeah,
How many
yeah.
sulfurs do we have?
1.
Just
right?
1.
7
2.
or 8.
I think it's 16 point.
32.06.
Oh, I was way off.
$32.08.
6.
And then
Four
we got
oxygen.
4 oxygens. 4 times
15.9999999.
No, that's 16.
That's 15.
Well, if there's that many 9s, just round it up.
Can't.
Okay. This is 2802.
Oh, I forgot it.
8.08.
Let's do it.
3206.
You only have to do 2 C.
That's gonna be, what's 17 times 4?
Well,
You're going to add up all 4 of those numbers.
Okay, Dave, redeem yourself.
3.
Alright, I will. Just don't say the answer out loud.
So we're figuring
Okay.
36
This way.
plus 32 is gonna be like 64.
Oh, it's in the
Wait,
hundred.
did I figure 64? Yeah, 125 or
Higher.
26.
It's gonna be higher than that.
Why?
Because that 8 and the 32, that's 40.
68.
That's
plus,
40
So
plus
172.
Now you're too
172.
high.
132.12.
Wait, what? We got 120. We got 128. Sure. Plus a
Few.
few.
You might as well just quit. while you're at it.
132.12.
Grams
Got it right on the
divided by
dot.
mile.
Let's
68. Yeah, I was thinking it was
Jeez, you guys suck.
60.
Okay, what if I were to just give you names? Do you think you could figure out the formula?
No.
Yes,
Sodium,
we've done this
S,
before.
H, and carbon.
Sodium,
Wait, what's
Yeah.
8?
Sodium,
Na.
we have Na,
hydrogen.
H.
A carbonate is polyatomic. You want to find that on the periodic table. So
You're
page
finding your
178 in your book. But I'll give it to you.
CO3.
So is that what we're gonna need a book for?
No, your assignments from your book.
Oh.
Ceruleum, hexaboride.
Yeah,
Ceruleum.
and you also got this one wrong, and I got it right first try. So
Where's that at?
I never said any.
Oh, this is a typo.
Yeah, you did.
Dave, I was brainstorming. I wasn't spitting answers.
I think it's supposed to
I
be
wasn't
cesium.
writing it down either, Dave.
You were spitting.
Yeah,
So
that's
you're
supposed to
not
be
taking
cesium.
notes, Andy? Is that what I heard? You just said you didn't
Okay,
write it
so
down.
cesium.
Dave, I can see your paper where you wrote down
Where's
every single
cesium?
number. and
Is
then
that
added them up.
Yeah,
right there.
Oh, why did I write
I used the
CE?
paper.
Because
What's
Steve
wrong
and
with that?
Landon are distracting the class.
Seal and Landon.
Hexaboride.
Same person. But like,
What's boride?
Dave.
Borax.
B.
Oh,
And then the hexa means what?
B6.
I'm all over the place right now.
Okay, magnesium perchlorate.
Mg.
Mg. I don't know perchlorate off the top of my head. Sorry.
Probably PC or something.
No, Drew's
Brooks,
got
you're
it.
lucky I
178.
sat on the brakes in time.
For what? What's Cook doing?
No.
Perchlorate.
No.
My cigarettes.
You don't
I didn't even grab my bird. Because I know I'm supposed to.
It's not there.
No, it ain't in here.
Okay.
Almost like Christian's car. before
It's
that.
ClO4.
They don't like the fish hooks.
ClO4. Seagull almost pegged my fish house. He was driving hammer.
Says you. I didn't have anything in me.
Oh, that's why.
I didn't.
Seagull's probably.
Not even.
He was probably liking it up there. I assumed he was there. You were
All right. So remember, guys, you also have to look at the charges on some of them. So keep that in mind.
Like that picture I took?
Aluminum. What's the charge on aluminum?
What?
The charge.
Charge, positive. Wait, what?
Yeah, positive what?
Okay.
Positive
3.
What's the
No,
picture you
yeah,
took?
picture.
Shut the door.
What's yes? You can check the door.
S.
Drew, send me the picture.
Sulfates.
I didn't say that.
What was
That's
it?
like 2 and 4.
Picture. It's Mom's
Oh.
SO4.
Yeah.
What's the charge on it?
Negative.
Drew, you should have saved it. You
Negative
can use it
2?
as blackmail against Tate.
Do the charges balance?
Nope.
What's a common number that they both go into?
6.
6. So what number do I have to take? 3 to get the 6?
2.
2.
So the AL2,
And negative 3.
How do you figure?
and this is 3.
Why do we have to get the 6?
Because the charges don't balance.
Oh.
So remember we have to balance the charges.
This is so confusing.
No, it's not. This is from chapter 5.
Yeah, that's a long time ago.
What about chapter 7?
We only did like 75 problems on naming ionic compounds.
I
Yeah.
got 2 wrong on that, so.
Yeah, that's about right.
Iron 3 hydroxide. So what's the charge on iron?
3.
Plus 3.
Plus 3.
So Fe. And then hydroxide is a polyatomic ion.
It's like plus 2, 4.
Minus 1.
Minus 1.
Oh.
And it's OH. So how many hydroxides do I need?
1. Or no. 3.
3. I'll put that in parentheses and I'll put 3. Tin to chloride, charge on tin.
Plus 2.
Charge on chlorine,
Negative 1.
negative 1, yep. So tin is SN. How many chlorines do I need to get to 2?
2. Wait, what? Yeah.
Yep, 2. Okay, this one's covalent. Tetraphosphorus.
10.
Tetra?
4.
4.
Oh, yeah, 4. I was thinking.
Decoxide?
That's
big. 5?
6. No.
No,
Yeah,
deck is
yeah.
2.
Deck is 10.
Oh.
Yeah.
Decade, yeah.
Iodine.
Iodine. That's I. And then monochloride.
1. CO.
Yeah, need the 1, Dave.
Dummy.
Okay, here's your homework assignment.
As Ryder said, CO.
I have a question.
But
Sure.
You know that last one we did?
for like the 3 answers. If you didn't have the percentage for like one of them, would you have to add the other 2 percentages?
And then subtract. Yeah.
That an answer. What page?
Page 236.
Jeez,
If you can
Oh God, I
read.
need a slice of paper.
I'm terrible at
You
it.
need a slice of paper, bro.
Alright.
Hopefully my math will be
Are you sure it's on page 236?
I think so.
No,
Not a chance. It's got a fire. It says cause of.
unless it's
No, it's at the
235.
Nope, 236 at the top.
Practice
Oh,
problems.
holy hell! I'm on 336.
Fire.
Where'd my pen
Fire.
go?
Okay.
1 through 2. 1 through 4.
I get a piece of paper.
Just together. Nice piece of jar.
Some wrong, boy.
Okay. Average atomic mass of a gallium, which is 60%.